Hello the internet and welcome back to my channel. Today I'd like to take a look at these Apple multimedia monitors. These should be 15 inches CRT monitors. I've got two of them and I don't really know in what state they are. I thought they were like faulty and then I was told maybe it's been like scavenged for parts. So I don't really know what to find inside these things, but I have access to a number of them. So the idea is to try and make as many as possible working out of all of them. For now I have two because they're quite bulky, so they wouldn't fit my car. Let's open them up and see what's inside. Well, one of the downsides of working on CRT monitors, which I'm not enthusiastic of doing to be honest, but I'm just curious, is that obviously these things are massive. This is not too big. I mean, it still fits my workbench here, so hopefully we can give it a go. What I've been told about these monitors, and honestly we don't know, is it could be like RMA monitors which somehow went back to the service center and they've been used for parts. We will know in a minute. These are Apple multiple scan 15 AV display, 15 inches I guess. This is from August 1996. I think I found a service manual of this thing, even though I think it's just a very basic service manual. And I've just noticed that this thing doesn't have screws, so it should open straight away. Well, one thing is sure, this thing is brand new. The flyback is shiny. I've never seen I mean, I'm not an expert when it comes to CRTs, to be honest, but the flyback is shiny. And the tube itself doesn't have anything, any dust, any soot, anything whatsoever. But this is definitely a brand new board. And look at that, LG. So this is manufactured by LG, and the CRT itself is a Gold Star CRT type M36LBL 803X. It's got tiny little speakers. I think that's the multimedia tag of the whole monitor. And unfortunately, I guess this repair is finishing before it's even starting. Because unfortunately, the tube is broken. The neck is broken there. Oh yeah, this is for the trash. Too bad. I have a feeling that could be why it hasn't been used. I'll check the other one. And the second monitor really doesn't promise very well. The plastic is bent. I can't think of the CRT surviving. But, let's take a look and see what's inside. Surprisingly, this seems to be okay, and it has an LG picture tube. It's funny that the Gold Star and the LG label, they look exactly the same, and product number is exactly the same, so I'm assuming the Gold Star is maybe like an LG company or something like that. I don't see anything wrong with the electronics, the fuse is okay. So to be honest, what I'd like to do is just try to power it up and see whether it does anything. If it doesn't, again, I'm not a TV repairer and CRTs are not the greatest things to work on. But, let's first power it up and see whether there's any high voltage at all, any picture at all, anything whatsoever. Okay, I've got the monitor, it's switched on already from the front. So as soon as I power it up, I should see something. And obviously, I have it connected to my current limiter just in case something goes very wrong. Right, I'm ready to power up in 3, 2, 1, go. So the monitor is drawing around 12 watts. When that happens, the bulbs are completely switched off, but it's making a clicking noise. It sounds like a short, but my light bulbs are not reacting. So maybe there's some sort of a short internal to the monitor, and the electronic of the monitor is stopping the power before, it gets too bad. But yeah, it looks like some kind of power issue. Now, a couple of online communities have recommended I check the horizontal deflection transistor, which is apparently known for going bad and causing the power supply for, trying to start as we see on this board. Now, I found this component here, which is marked C5129, to be a horizontal deflection output for high resolution display color TV. It's an MPN transistor and it's here classic base collector emitter things. So here we go, base collector emitter, base and collector. I see a junction, collector emitter, and there's a junction, this polarity, base and emitter. Oh, is that a dead short? Let's check resistance, because again, sometimes that can be, especially because it's in circuit. No, that's a dead short. That's interesting. I thought I checked this one. Well, I thought I checked them all, to be honest, especially the big ones. I don't remember seeing anything like that, but yeah, that looks like a dead short between base and emitter. Okay, you know what? Let's remove it and test it out of the circuit to be absolutely certain that that is actually faulty. Where is the horizontal transistor, horizontal deflection transistor? I don't see anything on it, but hey, let's plug it straight away into this tester. Wow, that's a big transistor. And let's see what it says. No, I mean, this is seen as a normal transistor, so I'm assuming if there is a short, it's somewhere else on the board, I guess. Let's check with the multimeter. Right, let's check again between base and emitter. No, the short is gone. Check with the resistance mode. Not sure it's supposed to read like that, but definitely there's no short. So let's check on the board instead. If there's still a short. Yep, there is. And it looks like a dead short. So let's see where this is going. And hopefully we can find what is shorted on those traces. I didn't record any footage about this problem, so I'm doing it afterwards with a picture. Now this is the back of the board, and this one is the horizontal transistor. You can see the base, the emitter, and I guess this is the collector. Up here at the edge of the board is, let's call it the ground plane or my ground connection. You can see there is a heatsink connected here. So during my test, I was sensing a short in between base and emitter. Now the emitter is directly connected to ground through this J80. J is jumper. It's basically jumped on the other side through a piece of wire. So emitter is directly connected to ground. Now the base is going this direction through a diode and a resistor on this trace, this direction here, and then it's reaching this transformer and it's basically joining the ground connection again. Now I did remove this transformer, and between this pin here and this pin here I'm actually reading a short, which I guess is by design. Now there is a diode and a resistor in the way, so I went and checked this resistor and diode, and I'd like you to remember this D702 diode, which actually isn't a diode. This is the other side of the board, and you see the D702, which is a jumper. It's not a diode at all. To be honest, I don't understand. I mean, that's a resistor in parallel with the jumper. I don't know what's the purpose the resistor is, to be honest. So this is not a diode, is a short, is a link. So obviously if I'm checking continuity between base and emitter, the emitter is going through ground, this direction here, up to here, into the transformer, basically reads the short with this pin here, back here, through the link, and back to the base, and that's why I'm reading a short. So I don't know why that's this design, but it looks as by design. So this to me is the dead end, and I might need to move to something else. Next, I started looking into the power supply section, which is a standard switching mode 1 as usual. I was checking components when I spotted these two large resistors in series with the MOSFET source pin. They measured very low at 0.8 ohm, but when deciphering the color bands to identify the nominal value, I was getting either 18 mega ohm or 56.8 ohm, depending from which side I was reading the bands. It did not make sense, and to be honest, I thought that very low value resistors attached to the MOSFET were to be expected. I checked on the other board I have, and the resistors were reading the same 0.6 ohm, but the other board was also exhibiting the same clicking issue. Was it just as easy as two shorted resistors on the power supply section on two different boards? No, of course. The badcaps.net forum community helped me identifying those resistors. I was told the fifth band, the black one, was for something else, and that those were indeed 0.6 ohm resistors. So that was fine, and I ended up in a dead end. So my next idea was to scope the switching controller IC. This is a KA3842B component, and it controls the whole switching power supply. It features a current sensor pin, and the datasheet says that if that line goes over 1 volt, it means there is an overcurrent, and the IC will shut down the operations to protect the circuit. So let's turn on the oscilloscope and check that line. This is the current sensing line when the power supply is clicking, and you can see the voltage is going up and down. Let's pause the capture for a moment, and yes, the voltage reaches 1 volt, then it shuts down, and so on. So it does seem that the power supply is cycling on and off because it senses an overcurrent then. So if I'm not mistaken, there's nothing wrong with the power supply and the issue is more down the road. So I turn my attention to the outputs of the power supply. Now this is the back of the power supply section. This is where the main transformer is. I can see that there are 3 pins which are connected together, so I'm assuming that is our ground. I can try and check whether I have a direct short on these rails. So I'm gonna check between, let's call it ground. Well, it does read a direct short. So I got 1, 2, 3, 4 and 5, but it's reading a short everywhere. Now I'd assume, obviously I'm reading the transformer coils as well when I'm doing that, but I wouldn't expect the transformer coils to read 0.4 ohms, to be honest, but maybe I'm mistaken. It's a bit confusing because again now everything is shorted basically. I'll tell you what, because this is a single layer board, so there's nothing soldered on the other side. It's pretty easy to remove components. I think I want to remove the transformer because that basically will isolate these traces, and hopefully if one is shorted I might be able to see it without the transformer in place. So let's remove it. Right, with the transformer removed, I've basically been able to draw the connections. Now, I know it looks like an angry face. It looks like an angry face. Anyways, the side here is where the mains is coming, or actually the switched DC coming from the controller, and these are the outputs. Now I can see that we have basically 3 different circuits, and where I have these dots here, I basically have ground on the board. So here on the transformer, again, this one, and this one are linked together, and I'm assuming this is to give a ground reference to the voltage, which would be otherwise floating. Now, if I'm looking at the PCB, I can basically see that each one of these lines are more or less all going through a diode. Now, for example, I have a diode here. It's actually quite nice because it tells you at the back what is connected to the front. So I got a diode here, and on this one I have a diode here. On this circuit here, I have a diode. It's a different package, but that's another diode. On this one, I have another diode here. It's again a different package. And finally, there's another diode here. So all these outputs, they obviously need to go to rectification. And I've been following these traces a bit. There's one line that has the voltage regulator on it. All of them have capacitors to smooth up the output. So all in all, we have 1, 2, 3, 4, 5 outputs. What I'm going to do now, I'm going to check with my Fluke multimeter to see if I can see an obvious short. I got the multimeter in resistance mode. I'm connected here on, let's call it ground, and I'm going to check on each one of the circuits. So I've got 3 mega ohms here, 1 mega ohm here, 10 kilo ohms here, nothing here, just kind of suspicious, and 2 mega ohms here. Now let's check what we got after the diodes. I've got still 1 mega ohm here. Circuit number 2, I've got something weird. I've got 51.1 ohms, which is a bit on the low side, to be honest. Well, kilo ohms, which is what I would expect. This one is still nothing, just kind of suspicious. And finally, I've got something that goes into mega ohms. So my suspicions at the moment are, well, one is, it kind of feels dead. But then we have this one, let's call it circuit number 2, which is reading kind of a low thing. Let's try in diode mode. Okay, it's reading kind of a short, even though again it's in diode mode. Now what I think I'm gonna do now, I'd like to try some voltage injection. The idea is, using my bench power supply, I can inject a little voltage into these rails and see if by any chance there's any component on the board which is overheating, because the idea is if there's a short somewhere, all the current that's flowing straight to ground is going through that single component which is shorted, which means the component will warm up and I should be able to see it through my thermal camera. So what I got here, I got my power supply connected to a ground plane, and I got some voltage which is coming out of this probe here. I'm going to inject some voltage on this rail and see what the current meter reads on the power supply. So let's try on rail number 1, more or less nothing. Let's try after the diode, still nothing. Rail number 2, okay, I got 100 milliamps, which is I could be okay, to be honest, but I don't know. Number 3, I've got 63 milliamps. Number 4, I got nothing. And number 5, I got 10 milliamps. We got something on 2 and 3, I think. So maybe I'll try and check with my thermal camera right now and see if I see anything getting warm on the other side of the PCB. Here I am ingesting voltage on circuit number 2, the one reading the higher current flowing. And yeah, my thermal camera shows a component glowing on the other side. It's a small transistor. You can ignore this one on the right. That's a reflection on a shiny heatsink. This is a wider view of the board. I don't see any more components glowing, so let's take a look at that transistor. Well, it looks like this is not a transistor anymore. So we might have found at least one of the components which is stopping this monitor from working. Now why this happened, whether it's just this or there's something else after this, we won't know, but I guess maybe I can just replace this. So here's the original transistor. It's a A1275Y. Now I couldn't really find, well, I could find a replacement, but it was like, I don't know, £4 per one. And I don't mind paying £4, but not for one, to be honest. So I have been looking online, and with a little bit of help at the same time from various communities, I ended up with this replacement, which is, I think it's a 2SA1013Y, which is basically identical. Now, checking on my component tester here, I do see it's a PNP. Now, I'll double check that the base collector emitter are in the same place, and then I'll replace it, and I guess this board is hopefully ready for testing. What I've also done, I've been checking all the components around that failed transistor, so finger crossed that was the only thing that prevented the power supply from starting on this board. Okay, the board is back in. I should have reconnected absolutely everything. This is still going through my current limiter, so you never know. I'm extremely curious to see if it works or not. In 3, 2, 1, go. Oh, it's not clicking. Oh, I hear something. Don't tell me it's working. Well, you know what? Let's turn it around, because I can't see anything here. But it's not clicking. It's powered, I think. No, maybe it's in standby? Well, I'm wondering whether maybe I need an input to make it work. But again, that's the great news. The power supply is definitely working. Now, I've taken a look at the user manual, and yes, it looks like the monitor basically doesn't work or doesn't fully power up unless there's an actual signal or computer connected. Now, as usually happens with Apple, this is VGA, but with a different connector. I was planning to make one, but I was waiting to fix the CRT first. So let me see if I can make an adapter right now. Now, I have a box full basically of D-plug connectors. I don't have a female of the 15 pins required by the Macintosh, I only have a male. So I really couldn't resist, and I ended up just bodging my own adapter using DuPont connectors. I've also fished out my Dell Latitude E6510, which has a proper VGA output, which is connected to the monitor, and we'll see what happens in a second. Okay, I'm about to power up the monitor. 3, 2, 1, go. Yay, high voltage! Come on, come on, come on. Look at that! Look at that! Oh. Right, that wasn't good. Right, whoa, 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 whoa. We got fire, we got fire. We got fire. Yeah, the same transistor, I think, caught fire. Yeah, this time badly. And I can see a charred component on the board. Let me show you. They actually look to be the two resistors which are close to the transistors. So I'm assuming there's something else which is shorted, and the new transistor has just caused another issue. It's kind of weird because it wasn't charred before, so it's kind of weird that now it decided to catch fire. And here is the aftermath of the accident, unfortunately. That one is the transistor I replaced, which seems okay. Well, probably won't be. But somehow there's a resistor, and I don't know what that is, but those have got bang. I need to double check with the CRT community. Again, I'm not an expert on CRT, I'm not an expert on anything, but particularly on CRTs, because I saw the screen went white. It felt as like the driving of the CRT was kind of maxed out for whatever reason. I'm not sure. Okay, I've removed the 3 components. Actually, I've removed the other transistor as well, just to check it. And it turns out the transistor I have replaced has shorted again. What basically caught fire was a small resistor. There were 2 resistors in there, and one is still working, and the other one obviously it went up in smoke, and that's the one that shorted. So now really it's a matter of understanding why the transistor keeps shorting. Right, I've been sleeping on this problem, and also I've received some input from a couple of communities. One is badcaps.com and one is videokarma.com. I'd like to thank you all those users who have been helping me with this project. And it looks like it could be, I shouldn't say that, but easier than I thought. So where you see this black mark here, that's coming directly from the power supply, okay? Whatever voltage it is, we can speculate in a minute. That is going straight through to the transistor which failed, which I found shorted in the first place. Q953 is going to the emitter. Now it's coming out of the transistor through the collector here, and it's going through a capacitor for a little smoothing up. And from here, this is going to this pin here of this connector. This is a connector that goes to the neckboard, and it says 70 volts. What looks like is this little section here made of 2 capacitors and a couple of resistors is a simple voltage regulator. So it's getting whatever voltage is coming from the power supply, which I'm assuming is higher than 70 volts. It's going into this transistor, and this transistor is controlled by this other transistor, which is either just switching this on and off, or potentially is regulating. And if I'm not mistaken, if I understand correctly, again, please remember that my knowledge of CRT is none. The 70 volts is the voltage which is driving the CRT driver on the neckboard. Let me show you what that is. So this is the neckboard. As you can recognize from the connector here, that's the one that goes at the back of the CRT, which is the neck, and that's why it's called the neckboard. Now, one of the main ICs on this board is this little guy here, and that is a video driver amplifier. So my understanding is this is actually taking the red, green and blue signals coming from this connector, which is more or less coming straight from the VGA cable, and it basically amplifies it, because obviously the signal coming from the computer is very low voltage. I think this is just amplifying it to something like 50 volts peak to peak to be able to drive the guns in the CRT itself. Apologies if this is not exactly correct, but that's a rough understanding. Now, this is the cable coming from the motherboard where we had the fault, where the transistor shorted and the resistor caught fire. You can see this is getting quite a few things, including 12 volts, 6.3 volts, if I'm not mistaken, that's the filament signal. Go ground, we go G1, then we have this 70 volts. And 70 volts is the voltage which our components, our affected components, are regulating. Now, the first test I did to diagnose this thing is to check what the resistance, whether by any chance we had a short on the 70 volt line, which goes to the little video driver here. If I'm checking ground with the 70 volt rail here, it's reading 108 and it's a fixed value, okay? And you might think, right, that's not short. But I have the luxury of having another neckboard. I have another system, which is not working, by the way, so I can't assume the one I'm checking is going to work. But I went on the other neckboard and checked the same resistance between the 70 volts and ground, and we'll see what I found. This is the other neckboard, it's still in its cage. Bear in mind, this cable is disconnected on the other end, so it's not really making any difference. And you see that here, I'm talking about, well, number one, I see a capacitor, because obviously that the voltage, the value here is changing. And I'm reading something which starts in mega ohms, and then it turns into kilo ohms. So there's nothing like that 100 ohm fixed. It sounds to me that we might have something wrong on the other board, and that's obviously assuming that this is working. I think what I'd like to do is to inject some voltage and check on my thermal camera if there's anything that warms up and any red flag showing up on my thermal camera. So what I've done now, I've got my power supply connected to the heatsink, which is connected to ground. I'm going to connect my power supply to the 70 volt line, and I can check with the thermal camera when I power up the power supply whether there's anything warming up on this board. Okay, first of all, do I have any current flowing? 3, 2, 1, go. Not much. It's the usual 100 milliamps. Well, I don't see anything obvious on the board. We try with a higher voltage, 7 volts. Okay, 7 volts, we have 300 milliamps. Okay, now you see something warming up finally. And yeah, it looks like it's the it's the main IC. Yes, there's a clear short inside the main IC. This is actually pretty cool to see. Look at that. You can clearly see there is a clear short inside the main IC. I mean, it's there, 100%. And now I got 7 volts out of the power supply. I didn't realize the power supply was limiting. So over a certain voltage, this thing has started warming up quite a lot. And out of 7 volts now, I'm going up 600. So it's going into, I think it's called like some sort of avalanche effect, if I'm saying that right, where it basically starts warming up and it gets warmer and it draws more current, and then it gets more and more and more current. That's exactly what happens to the board. That's why the board went up in flame. Okay. Time to replace components here. Thankfully I have a spare board, so I measured the burnt resistor values from that one. I have the spare parts for the board, so what I'll need to do, I'll need to replace the 2 resistors and the shorter transistor. Also, I will have to replace the neckboard. I'm going to replace it with the other one rather than just start replacing components. So let's get going. So this is the replacement neckboard. It's still caged. I honestly don't know whether this is working or not. I was thinking I will inject the same voltage that I was injecting on the other one on this one and see if by any chance my power supply is reading something weird as the other one. Let's inject this 7.2 volts, which is again as it was before, and see what happens. In 3, 2, 1, go. So now, as you can see, there's no current flowing whatsoever. But again, the other one was snowballing at this point. It was just overloading my power supply, and there's absolutely nothing going on here. So hopefully this means that at least that chip is not shorted. Now, whether this is working, that's an entirely different story. But let's be optimistic and replace it and see what happens. Okay, I'm ready to power up. The multimeter on the left is connected to the test point of the power supply. It should read 50 volts if the voltages are okay. The one on the right hand side is connected to the 70 volts line, and it should read 70 volts. Okay, in 3, 2, 1, go. Okay, high voltage is on. 50 volts, we have 22 volts. That's not right, but let's see again. The monitor is horrible. We do have a picture this time. It's not smoking. The voltage from the power supply is totally fine. The monitor is still on, but we have 30 volts and not 70, unless I've connected it in the wrong place. The monitor is on. Is that a good sign? The power supply is working totally fine. The blotches are probably just a magnetized tube. This looks like it needs a full calibration, because obviously I swapped the neckboard. Yeah, now I'm thinking about it. The neckboard is from another tube, so obviously the picture is messed up. But at the moment, I have a picture! Yay! And there's no smoke and sparks. Would you believe it? Well, I guess the next step would be, first of all, to let it run for a little while and make sure that it actually works. Then it would be a matter of opening the service manual and following the process to readjust the white balance, black and white levels of this CRT. Okay, before I proceed with trying to adjust the picture of this thing, I think I'd like to look a bit into that 30 volts on the 70 volt line, because I have a feeling that I'll be wasting my time if that 30 volt line is actually supposed to be 70 volts. I think we have a few scenarios here. Scenarios number one is the PCB is wrong, it says 70 volts, but it's not 70 volts. I mean, I've seen them before. That being said, the datasheet of the CRT driver says 80 volt VCC, so that seems to be consistent, but not the same of what the PCB says. Well, scenario number 2 is that this VCC is somehow variable. Now, the CRT driver, if I understand correctly, is just an amplifier. I think the amplifier has a 50 volts peak-to-peak signal. Maybe that's not required with this picture tube. To reduce that, they just reduce the input, the voltage input. I have no idea, I mean, whether that's a linear thing that you can do with that chip. I have no idea whether I'm saying rubbish here, but maybe that's a possibility. Another possibility is that somehow that voltage is driven by one of these adjustments. And maybe there's like an overall brightness adjustment somewhere, which is talking to the regulation on the board and raising the voltage to up to a maximum of 70 volts. That could be a possibility too, I do not know. The last scenario is obviously there's something wrong with the board where the voltage is regulated, and obviously that would need to be fixed. What I intend to do now is a couple of things, right? Number one, I'd like to check the voltage going into the IC straight on the neckboard, so on the actual VCC leg of the component. I really want to confirm that those 30 volts are getting to the IC. If I still get 30 volts, I think I'd like to play with the streamers a bit. I'd like to see if by any chance, by touching any of the streamers, there's a change in that voltage. That would tell me that there's some kind of feedback between the neckboard and the motherboard, and those two transistors that we replaced, they're actually regulating the voltage based on what the neckboard is saying. Finally, I'd like to check the voltage going into the regulation that we fixed on the board, the regulation that failed. If I'm supposed to have 70 volts out, I'm expecting more than 70 volts in. If I'm getting 30 something volts in, well, I guess that's probably a problem, and I have to go backwards up to the power supply and see what happened there. So first thing first, I'd like to solder like a pin or something on the VCC leg of the CRT driver. Then I'll plug my multimeter in there, we'll power up and see if the IC actually gets 30 something volts, or if for whatever reason it actually is getting 70 volts. At that point, all of this is just waste of time. Okay, I've got the multimeter connected to ground and VCC on the CRT driver chip IC, and I guess I'll power it up and see what it reads. 3, 2, 1, go. And no, we only have 23. It's even lower than yesterday. And I do have a picture on screen, yeah. What I'd like to do, I'd like to play with these are basically colors adjustment, brightness adjustment, contrast adjustment, and see if by any chance that voltage changes. So this is called sub brightness. It does a bit. Okay. I'm gonna operate the brightness at the front panel. So if I turn it down, oh yeah, 26. If I'm going up, 30, 33, maximum is 34. So this is kind of an inconclusive test, to be honest, because yeah, I see a change, but it's not enough. Probably I could try and just realign the monitor and see if by any chance it works. Just before I do that, I'd like to find a test point or somewhere on the circuit where I can test the voltage going into the regulation and see what kind of voltage is going into those transistors. I'm powering up in 3, 2, 1, go. Oh yeah, we have 70 something. So yeah, so fair enough. So that's telling me the line is working fine. So it looks like the power supply section is working. So either that regulation is not working, or the regulation is going down to 30 something because that's how the monitor is adjusted, and that's how the monitor wants that voltage. But I would say the next step is to grab a mirror and set up some cameras and see if I can follow the service manual and adjust this CRT. Okay, I think I'm ready to start. I have a grayscale connected to which should appear on the monitor when I power up. I guess let's power this up and make sure we have a picture first. So that's 3, 2, 1, go. Well, Fummina un'altra volta. Okay. Oh, I know what I've done. Oh, I'm an idiot. Well, that's my fault. I put the cover back and I didn't remove the leg which was going on the VCC. So I basically shorted the same lines. I'll have to replace the same transistor and the same resistor again. So that's my mistake. I left that pin. I forgot it there. I put the cover back. The back is shielded and I basically shorted the 70 volt line again. Yay. Okay, I've replaced the same transistor, the same resistors. Will it work? I'm not extremely optimistic, to be honest with you. This project is not going very well. I mean, it's kind of expected. I'm not an expert when it comes to CRTs, and to be honest, I don't feel too comfortable in playing with that. But anyways, let's give it another few goes and see what happens. The flux meter is connected to the 70 volt line, which reads 30 something. Well, and let's power it up and see what happens. In 3, 2, 1, go. 68. Oh. Okay. Is it a good sign or a bad sign? Let me switch it off. Was my transistor faulty? But no, I don't have a picture. I do actually, it's very faint. It maybe means it's working this time. We definitely have a picture with wrong colors, but those are totally adjustable. It's definitely much better than before. I have no idea what happened. My 70 volt line now reads 64, which I guess is fine. It's much better than before. I mean, the grayscale is all off, but again, that needs adjustment. Okay, I guess we can try again with the adjustment and color calibration of the CRT. Now, before I begin, the service manual says that every time the deflection board, which is the main board, is replaced, the high voltage needs to be adjusted. Now, thankfully, there is a procedure to check the high voltage without actually checking the high voltage at the suction cup there. There is a small diode by the flyback transformer there. I got my red probe connected there, the ground one is on ground, and then high voltage can be adjusted with one of these two trimmers here. And all I have to do, the service manual says, I have to look for 42.5 volts. So I'm not actually reading the high voltage, I'm reading some kind of a circuit, and I guess, whoever designed the service manual knows that 42.5 volts matches the exact high voltage the set needs to operate properly. Now, the only thing the service manual says is the resolution that you should use for this adjustment is supposed to be 640 by 480. Now, my computer there doesn't do that resolution. I can only do 800 by 600. I hope it's the same thing. Does the high voltage changes with the resolution? Well, maybe, I'd like to take a look, see how far away we are from 42.5. Then I'll make a decision whether to adjust it a bit or maybe ask for advice before I touch the high voltage. In 3, 2, 1, go. Well, we're getting the picture, which is a crosshatch, and to be honest, the high voltage looks to be, I think it's more or less fine, because it's supposed to be 42.5 plus or minus 0.2, so it's mildly off, but also the monitor has been on for seconds, and I'm supposed to wait at least 5 minutes, and I can see that voltage is slowly going down. So I would say, let's leave it for the time being. The voltage is probably totally fine. Well, since the CRT driver voltage seems to be fixed, and the picture looks much better, though not calibrated, it's now time to run through the picture adjustment of this monitor. The adjustment is done by tweaking two main parts. First is the color balance. That makes sure that the amount of red, green and blue is as similar as possible throughout the various levels of brightness displayed by the picture tube. This is why I will use a grayscale test button to adjust it. On this monitor, blue is fixed and I can adjust the red and green to balance. Second is the screen adjustment. These adjust the black level, that is, whether the black is actually black and not a light grey, but without crashing the darkest tones of grey either. To adjust the colors, I have two set of controls for red and green, bias and drive. Bias adjusts the RGB balance at low levels and drive at higher levels. Obviously, these controls interact with each other, so it takes a little back and forth to get good results. It's interesting that these names, such as gain, bias or offset, are sometimes still found in modern monitors or projectors. Those names had an electronic meaning on CRT monitors and TVs, as they represented the voltages used in the various parts of the tube. but they don't mean anything anymore on modern screens, but somehow the legacy names have survived the evolution. At some point I dug out my little color meter. It's a device which analyzes colors and displays them on a graph, allowing to do more precise calibration of monitors. However, the control adjusting the dark and bright parts of the picture were interacting with each other so much that at some point I just gave up and used my eyes. The outcome, besides those blotches, is pretty good. The tube is not very bright, but I guess I might be used to more modern LCD panels. I'm reading 156 candelas at full brightness, which is probably pretty good for a CRT. On those blotches, I am told that those are likely physical damage of the internal shadow mask of the picture tube itself. Lighter color patches could be fixed by the degaussing circuit, which is basically a strong magnetic field run around the tube when the TV is turned on. But those are too sharp and bright for being just magnetic issues. I could try with a manual degausser, but I do not have one and they're expensive. I did try with a strong magnet, but those concentric circles would not change at all, so I'm afraid this monitor will need another tube. The only concern I have is that the degaussing circuit seems not to be working on this monitor. Or at least I don't have the usual wang sound when I power it up. The circuit is simple. A relay sends mains voltage through a coil wrapped around the face of the CRT. The 50Hz mains alternating current generates a strong magnetic field which should even out any magnetic charges present on the tube itself. On this monitor, the circuit is automatically energized at every power-up for a few seconds. Then the relay cuts the power off. The main component to prevent the coil from melting is a thermistor. When cold, it acts as a short. But as it heats up, its resistance rises fast, and as a result, the magnetic field is quickly faded away before it's switched off by the relay, which is what you want to avoid magnetic residues on the tube. I tested the circuit with my oscilloscope, and I could see the alternating current flowing through it, even though for a very short time, and I'm not sure that is enough to be honest. But then I unplugged the degaussing coil and tested without it, and I could see full mains for as long as the degaussing relay was energized. This is expected, and it is because there is very little current flowing, hence the thermistor does not heat up. I then plugged a 15 watts light bulb where the degaussing coil would go, and it lit up as expected when I power up the monitor. Again, 15 watts are not enough to warm up the thermistor, so it acts as a short all the time. So the circuit seems to be working. Whether it should be a bit stronger than that, I do not know. But honestly, I feel it's pointless to invest more time on this set unless I find a replacement CRT. As it stands, I think this is the best I can do. Well, this is it for this video. Did I fix this monitor? Well, I guess so. There's really not much I can do besides replacing the CRT. I can't fix that CRT apparently, and I fixed the PCB, so that's good. That was my first CRT, so I feel good about it. I didn't feel very good when fire came out of that board, but anyways, let me say that I really didn't feel too comfortable working with the CRT. The too many high voltages, the high voltage, the mains voltage first of all, the high voltage for the CRT, and lots of higher than I would like voltages in the board itself. I mean, if I do something wrong on the motherboard, you might have a little bit of smoke, but you don't have fire as this one. So we shall see for the future. I'm not sure how many more CRTs I would like to work on. That being said, have a couple of these to fix. These are the Apple IIc small CRT monitors, and yes, they're still CRTs, so they're still kind of dangerous, but I don't know, they're too cute. They can't be so dangerous, can they? So these are coming in a future video, so watch this space. Well, that's it for now. I hope you enjoyed the video as usual. If you did, please go ahead and hit the like button down below. I would really appreciate that. And feel free to subscribe to this channel if you feel you like what I'm doing here. For now, as usual, thanks for watching. I wish you a great day, and I hope to see you again soon here on my channel for my next videos. Thank you very much, and goodbye. Bye.